Good afternoon. I would say good morning because I'm coming from Brazil, and believe me, we have a great difference in time zones here. It's actually 13 hours. But good afternoon. Thank you for being here. I am Jaime da Riba Macedo, and I'm the Study Committee C2 Chair. And it's an honor and a pleasure to be here in this very well-organized symposium. And this is the first event of our study committee in the symposium. We will have paper presentations on Wednesday, Wednesday the whole day, and Thursday afternoon. Tomorrow we will have an internal study committee meeting. And but this is the first event. It's my pleasure to say to you that we will have today, during this afternoon, 2 tutorials. And it's great to say that all the presenters are from Australia. It's good to have people from Australia with us. And both tutorials will tell about very interesting issues. And the first one will be the one presented by our friend Franco Crisi, the Italian right pronunciation, okay? Frank was a convener for a study group that works a lot with other contributors, or with, I don't know the final number, it was like, yes, a great number. He will talk about this during the presentation, and it is my pleasure to give you the information from the great bio from Frank. I will summarize it here, okay? With more than 40 years experience in the electricity distribution business, Franco Chris has been responsible for the delivery of a number of significant projects, for sure. They include project managing the conversion of thousands of kilometers of bare lines to insulated conductor, developing and implementing comprehensive bushfire risk management procedures, and establishing and managing the distribution control center in South Australia. Okay, and from now on, please, Frank, the floor is yours.
Thank you.
An applause for him. Yeah.
Thank you very much.
You will receive more applause.
I hope that continues at the end as well. Yeah, the first session after lunch, so I might have to be a bit animated to keep you all awake. So, see how we go. I hope this is of interest to both groups managing transmission and distribution utility businesses, because the nature of what I'm going to talk about affects both businesses. So that's me, as James said, 40 years experience. I was the convener of WG C224, and we published the technical brochure in 2022. Why this area of study? That was the first thing. So in about 2017, I've been working in bushfire risk management for a number of years, as people in the room who know me are aware of. And I felt that there was a bit of a need to bring that knowledge together, because catastrophic bushfires or wildfires, I might use the two terms interchangeably during the presentations, start from electricity assets, we know that. Electricity caused fires, typically only a small percentage, but a disproportionate loss of human life and property compared with other fires. And they affect both transmission and distribution lines. With climate change, there's a pretty good chance of an increased likelihood and number of catastrophic bushfires. So utilities need to think about mitigating the risk of starting a fire and the consequences of the fire. So as James said, we had this group of people involved in the working group. So there's a bit of diversity there. And you can see the interest mainly from people with fire scenarios. So USA, ourselves, South Africa, Canada. Canada was a surprise one. USA, Spain, but Joachim was from Spain, but currently works in the USA. The objective of the study was to collate industry best practices in bushfire risk management. So what I wanted to do was bring together all of the smarts that people are doing around the world to give a utility that's facing this problem for the first time a sort of a checklist of what to do, how to go about it. And distribution businesses are typically concerned with starting a bushfire from their power lines, whereas transmission companies, albeit there is a tiny percentage that have fires starting from lines, but by far the majority of the effects are the effects of the bushfires on their lines. So the methodology for the best practice collation was to bring it together into an emergency management PPRR framework. The reason for that is that then you've got the various phases of this whole risk management process encapsulated into those 4 steps, and I'll show you how that comes together during the presentation. The starting point was to issue a survey for both distribution and transmission utility companies. Some of those questions were around statistics, regulatory framework and legislative frameworks, how they go about assessing their fire danger. And one really important thing that maybe gets missed a bit is that utilities are, particularly when it comes to emergency management, which is a field that I was with in my previous role in SA Power Networks, you're part of a bigger community issue. So when there's a bushfire, when there are storms and whatever, the utility is just one member of a greater state-based emergency management response. So the interface of utilities with emergency management responses, emergency management organisations in their states is a really, really important aspect, and I'll cover that a bit further. So the structure of the technical brochure is an introduction, distribution utility practices, chapter 2, wildfire start statistics, etc. I won't go through all of it. And then the best practice findings and the conclusion at the end. So fairly standard sort of structure of the technical brochure. So the surveyed utilities, we got responses from mainly people who had a history of wildfires. We did have other sort of responses, but the quality of them was a little bit varied, I'd have to say. In the end, there were 27 surveys that I could use. 10 surveys from 5 utilities that had both transmission and distribution, so they gave answers in both those spaces. 4 distribution only, 13 transmission only. As I said, the quality varied a bit, and the people with a history of major bushfires had the most comprehensive plans and management strategies. This is a bit of a summary of the impression I've got from the way the information was supported on the attitude to bushfire risk management. Transmission companies see it as business as usual, whereas distribution businesses see bushfire risk management as their number 1 corporate risk. In Australia and California being 2 typical examples of that. What's happening in America is a lot more of the utilities, even in the Midwest and over to the east side, are starting to realise that with climate change, they have to be much more responsive to bushfire risk management. So operations on elevated fire danger days, distribution utilities disable, reclose, there's power shutdowns, transmission, it's just business as usual. Vegetation clearances, a significant issue for distribution, not so much for the clearance distances. Emergency management planning, transmission tend to be a little more relaxed, if I could put it that way, on days when it's extreme fire danger, whereas distribution utilities are up to their eyeballs in managing. Bushfire start on extreme fire danger days, very rare from transmission. With distribution, often. Consequence of bushfires. With transmission, this is one of the things that transmission companies maybe forget and why they need to be focused on this. You lose hundreds to thousands of megawatts, and I'll give you examples of that. In the case of distribution, it interrupts a few thousand customers. So it's a significant different sort of scale of consequence. So typically what happens, catastrophic bushfire. So insulation fails, fault current flows either phase to phase or phase to earth, and a fault leads to an arc. Protection operates to clear resulting fault. And during the fault clearing time, the arc expels hot metallic sparks. The sparks contact dry combustible material, and the dry material ignites and results in a sustained flame. The flame is fanned by winds on extreme fire danger day, so the fire grows and spreads. And the spreading fire escapes into an area of large quantities of fuel. The bushfire results and is not suppressed by the landscape. For example, if it was halted by a bitumen road or a watercourse. And firefighting resources are so busy on those sort of days that they're unable to attend until the fire is out of control. The bushfire burns for hours, causing catastrophic devastation, lives, fauna, and properties lost, as evidenced by a picture like that from the New South Wales fires. So you can see that there's quite a sequence of things that has to be, all the holes in the Swiss cheese model have to line up for the fire to be a significant fire. And fires have unfortunately, the characteristic of changing a landscape like that to looking like that. So it's imperative on us as utility operators to be cognizant of that. One of the things we compared was how the utilities in Australia and California in particular compared or assessed their fire danger, and it's pretty much similar. There's fuel, there's weather, then that's combined to determine an index, and then based on the index, actions are taken. So there's pretty much similarity of understanding of the mechanisms of fires and what is a bad fire danger day. So the imperative to take action on fire risk mitigation. So the urgency for utilities to understand fire ecology, fire start probability has never been greater. And climate change is exponentially increasing wildfire intensity. So at this point, I just want to give you a bit of background before my next slide. I'm part of an international wildfire risk mitigation consortium, and I know there's other people in the room who are, and utilities like SA Power Networks, PowerLink, are members of that consortium. It consists of USA and Australian utilities in the main, transmission distribution, and their aim is to collaborate and bring together what we know about wildfire risk mitigation. And presentations are made by subject experts. There was a presentation made by a Spanish firefighter, Mark Costello Ribal, I hope I've pronounced his name right, captain of firefighting in 5,000 firefighters in Catalonia. Catalonia, for those who don't know, is in the northeast corner of Spain. It's made up of 9 million people in that area, a relatively densely populated area of Spain. They have thousands of vegetation fires each year, a certain percentage of which, 18 to 20%, are caused by power line interaction. Not all of them are serious fires, but in recent years, what they noticed was a significant increase in the fire intensity. So they conducted a study of this phenomenon. And the high intensity fires was due to a couple of factors, main factors. The socio-economic changes. What was once agricultural farmed land, irrigated, has become forest bushland because it's untended. And climate change, the temperature increase, what that does is it increases fuels, the dryness of fuels. And you have more fuel, drier fuel, so clearly the elements are there for a fire. And once a fire gets into a forest or bushland, as anyone who's ever been with a firefighting agency as a volunteer would know, you just can't stop it. So just keep this statistic in your mind, in your head, 10,000 kilowatts per square metre, or per square metre, is the firefighting limit. So beyond that, a firefighter can't be protected by the gear they're wearing, their PPE. In the 1990s, the fires were rated, so this is as a result of the study, were rated at 30,000, so 3 times the firefighting PPE limit. In the 2000s and 2020s, etc., it's 90,000, so 9 times the intensity. So let's have a look and see what happens when a fire gets out of control. So this is the phenomenon that the Spanish firefighters were dealing with. So what's happening there, you've got this pyrocumulus cloud forming, and at one point it just drags everything from underneath and creates this plume, this huge plume. Now, as a result of that, with all of the winds that are caused in this local climate that's happening in that area, and here's what happens. So this is an area, so you see that camera, so that's the fire, it's spat out, it's become a huge fire, it's engulfing everything. So that's moving meters, many hundreds of meters out into the landscape and consuming everything. This is why it's imperative for utilities to understand fire ecology, because that stuff is around the corner and we need to understand that and need to deal with the risk of that happening. So as a result of their study, they undertook and came up with a comparison. I won't go into the details of it other than to say that fires have moved from, rate of spread of 5 meters per minute to 300 meters per minute. The fire flames, tend to fire from a few meters to, 150 to 100 meters. So there's been a huge increase in the intensity of fires, and this came about from the results of the study undertaken by these Spanish firefighters. So remember that figure of 10,000, then it's 10,000 kilowatts per metre. This is Black Saturday in Victoria. What you've got there are different lines of fuel. So the question was, is it fuel-driven or weather-driven? And most of the areas where this occurred, the climate was pretty much similar, right? What the difference is the fuel. So you can see what happened there. In the area where the fuel was 30 tonnes per hectare, it's got up to 90,000 kilowatt per metre. Remember I said 10,000 is where the firefighter's safety is compromised. Look at that. So it's not surprising you get these intense fires causing heaps of issues. So what's this mean from a firefighting point of view? It means they have to change their firefighting tactics. Now this is relevant for us as utilities, because if you're trying to stop a fire from happening, you have to understand the fire ecology to understand what your risk is. It needs more strategic fuel management processes. In 1990s, the pyrocumulus storm clouds that we saw, that I showed you in that picture, required fire size of 1,000 to 10,000 hectares. Now it's only 10 hectares to 20 hectares, because that fuel and the way the climate has changed just makes this cumulus cloud occur much more frequently. So the upper atmosphere, which is colder, had to create more energy to disturb the upper atmosphere. Now, because it's warmer, you don't have to create as much energy to trigger that magnitude pyrocumulus cloud that we saw. So they're looking at strategically managing their landscape to avoid large fires. So in the Australian context, we got this statistic following the Black Saturday fires. You can see there that on total fireban days, 0.8% of fires of the fires in Victoria were caused from power line. But on Black Saturday, 1.7 to 3.4, in other words, twice or 4 times the number of fires normally on total fireban days occurred. So what this points out is that on extreme fire danger days, electricity assets are a problem, potential problem. In California, the scene is the same. You see there, acres burnt. The majority of, so this was from 2021 Wildfire Activity Statistics, California. Electrical power, 284 incidents, but look at the amount, they've got the lion's share of the acres burnt. So, and as we know from things like the Camp Fire, for example, that tested Pacific Gas and Electric. So you can see electricity-caused fires are something we need to be aware of. Now, transmission line flashovers affect system security. So transmission companies, you're not out of the woods because your power line is right up there. Have a look at these events over a number of years. So in 2019, the 132 kV network in South Australia, where I'm from, loss of supply to 25,000 customers when there was a flashover. In New South Wales, as we know, fires under the 330 and 500 kV systems. There were lots of line faults. The Q&I interconnector was lost. Flashover occurred there. In SA Victoria, we lost the interconnector in 2004 when a twin circuit 275 kV line flashed over. Automatic load shedding in those days. In continental Europe, that's the biggest one of the lot. If you have a look at that, two-phase short circuit, 400 kV line, 4,872 megawatt load shed. There was some scrutiny paid to the organisation that runs the whole interconnected network in the Central European transmission system, because there was a feeling that they shouldn't have been allowed to let go that much. So AEMO, be on the lookout. In South Africa as well, fires under 765 kV lines. Have a look at the frequency drop to 47.72. That's serious frequency drop. And in New South Wales again, we've had those losses. So you can see transmission lines aren't void of things happening from fires. That's why this study was about both transmission and distribution. So again, this talks about the potential flashovers that stem from fires, and as you get up in volts, then you can see face to ground faults come into it in this column here. At the lower voltages, there's just not enough volts to flash to ground, but as you get up in volts, mid-span, face to ground faults become much more probable. And the effects of bushfires on transmission lines, particularly repeated flashover. So this was a photo taken from PowerLink, an extract of that manual. You can see the effects on the line. So repeated flashovers do cause issues, and I think that's something transmission companies need to be aware of. So let's have a look at some of the strategies that the distribution utilities are undertaking to alleviate the risk of fire starting. Altering protection on elevated fire danger day, modelling fire propagation to classify fire risk areas and prioritise their mitigation work. Detection of incipient fault technology. I'll describe what that is a bit more. Detection of conductor brake technology. So this is when a conductor breaks and you identify that before the conductor hits the ground and you switch the circuit off. Pretty good technology. A decision-making framework for shutting down power. So when do you shut down power? So I'll go into that a little bit. Commissioning studies into fire behaviour, because as I said, those sort of super fires, you need to know where that's happening, where the potential for that to happen is, so that you can prioritise your management of your network. And working closely with firefighting agencies. Really important, as I said before, because you're just part of a bigger picture as a utility on those sort of days. So, wildfire statistics, around 2/3 record power line fire statistics. It's required to report to regulatory agency. That's when they become more sensitive to it. Only a few record the weather at the time of the fire event. That's a really important piece of information to be aware of. What happened as a result? What was the weather at the time? Collecting statistics clearly highlights trends. It reduces the uncertainty in what your asset is doing and focuses your asset management priorities. Vegetation-caused fires. Less than 20% of survey respondents record the type of vegetation that caused the fire. Again, that's another strategic bit of information. Is it pine trees? Is it gum trees? Is it what type of tree? What type of vegetation is causing us a problem? That is important from a fire risk mitigation point of view. Commissioning studies, research into fire start mechanisms and fire propagation. How does a fire start? How does it propagate? Because it can fundamentally change the way you go about your risk management practices, and improve your understanding of fire ecology. Working with agencies, as when I was in SAPN, we worked with CSIRO on fire propagation. Very important. In the USA, the development of DFA, distribution fault anticipation technology. One of the members of my study committee, Dr. Don Russell, Professor Don Russell from Texas A&M University, he was involved with EPRI to develop this technology, which I'll talk about in a little while. Rate of vegetation outages versus wind speed, that was one thing we commissioned so how does vegetation incidents compare as the wind changes? What happens? And of course, you get more interaction. And quantifying consequences of catastrophic fires. So modelling fire propagation, because you've got limited resources, you have to deploy them to the most critical areas. So that's why you do it. It affects the way you inspect your asset, how you construct the asset. Some areas you'll put it underground, or you'll replace it with other conductor, insulated conductor, and some areas you'll leave it as bare. So predicting potential fire sizes, that's really important to know where your asset is most vulnerable. And typically people use a high, medium or low fire risk area classification. And the modelling involves hundreds of thousands to millions of studies of fire size and consequence. And then you aggregate that and you come up with the most probable event, and that then drives how you go about doing your strategy of prioritising your asset management. And one utility does a daily run of these fire consequence on that day. I've got this weather, run this model for me, and then they work out if the weather does actually happen over here, that's where I'm going to switch it off. So they do on the fly calculations. Protection setting changes. So on the Royal Commission into the Black Saturday fire said the reclose function was not suppressed. There were 4 trip and close operations. This is the Kilmore East fire, people who are aware of it. The arcing produced plasma of 5,000 degrees C, expulsion of metal globules, and as we saw before, globules hit the ground, dry fuel, off goes the fire, fanned by these strong winds. So they've legislated they didn't legislate for rapid earth fault current limited. They legislated that the protection needs to intercept the ground of earth fault in less than, and produce an I2T of 0.1. And the only technology that's supposedly around at the moment is RefCall. So that's how it became. It's said to reduce faults below critical fire start risk levels. Works for face to earth, but not face to face, and it doesn't work with SWIR. And reports are mixed on the effectiveness of the technology. Anyway, I'll leave people to make up their own minds on that. Transmission lines disable reclose when fires within the right of way. You know why? Because if you're getting multiple face-to-face trips, you see what happens to your conductor, and also the instability that it can cause. We saw in those 5 or 6 incidents, you lose supply. So transmission companies, be aware. So fire start causes, typically vegetation, bird or animal, broken conductor to earth, load side of break. So people probably aware of this, the source side still hangs up in the air and the load side hits the ground. You can get fires starting from that because that's a live conductor on the ground. And all of these types of fire start causes were reported in the survey. Fires can start when defects cause current leakage below the pickup levels of protection equipment. That's really scary. Partial discharge on wooden cross arms, right? So you've got this protection sitting there and it doesn't see a fault, even though there's partial discharge happening because it's below the pickup levels of your protection. Protecting systems is really, it's a black art. Wind effects on power lines, you see that's an actual photo. Can you see that the 2 conductors on the going that way are missing? Because that piece of metal flew up in the air and landed on the power line and we lost a couple of conductors. So loose metal, loose plastic can do this. Off goes the globules and the fire starts. So this is a known phenomenon and we've actually seen it. This is called synchronized conductor swing. Nothing to do with synchronized swimming. On Ash Wednesday 1983 in South Australia, we had this circumstance. 1 phase was steel, 1 phase and 2 phases were copper. So what happened? The wind was blowing, the conductors struck, didn't they? Threw a whole bunch of globules to the ground, and all of a sudden we had a circumstance like this. I've heard of people attending breaks in conductor and putting up whatever conductor there is on the truck and just putting that back in the air. This is a reason for not doing that, to stay with the same conductors. The other thing you need to do, and what happened in South Australia post Ash Wednesday, was to triangulate the network, because at that stage it was all flat. Ensure all three phases have the same conductor. So construction standards, transmission. While they don't typically start fires, there's a whole bunch of new transmission lines about to be constructed. It would be great to choose areas where there aren't high fuel volumes, or areas with history of bushfires, if you can. Now, that may be easier said than done, and putting it underground just ain't an option, because we know the cost of doing that. So conductor spacing, insulators that can withstand sooty deposits from fires, withstand fires of flaming temperatures. Remember the height and type of materials for structures. Remember, some of those fires can reach quite high, and they're getting bigger. The flames are getting higher and higher. And again, it's all about money. The higher you put the thing up, the conductor up, the higher it's going to cost, but the lower the risk of something happening. But those are some of the sort of things that you need to think about. Distribution, the 9 organisations or 9 surveys that we had, all designed to international, national or regional or regulated set standards. Most have triangulated bare in high fire risk areas. Some use insulated. Most have defined conductor replacement programs. So they're all trying to reduce the fire risk. Utilities are investigating microgrids. You might be aware of that. And particularly in WA, it's happening. In California, they're doing that as a strategy to overcome the fact that they switch the power off, right? So they have a microgrid at the end of a long line. They can switch the line off and the people at the end of the line still have power. Wildfire impacts on overhead bare conductor. You see, that used to be nice and shiny silver. It's white. It's white because there was a fire like that. Now, I don't know how many people here have been to Port Lincoln. Probably not many. Maybe the South Australians in the room know Port Lincoln. If you know Boston Bay and you see that looks like Armageddon. That was a fire at WW. I've forgotten what it was called. Help me, Catherine. Yeah, the upstream of North Shields. Anyway, it was tens of kilometres away from Port Lincoln. But the consequence of that fire led to this amount of destruction. It was just enormous. And as Catherine said, it eventually stopped at a place called North Shields because there was some water around there. It stopped at the beach. That otherwise it would have kept going. It's just crazy. So these fires, remember, they're becoming bigger and bigger. This is a way to stop a fire from propagating. Grow a vineyard. You see the green patch there? The fire continued, and where there are green vineyards, the fire actually burnt a little bit, but it stopped. But the wine in that year was a little bit soiled. Conductor reconstruction. So if you want to stop this sort of thing happening, then you put in insulated conductor. So you've got both ABC, aerial bundled cable, the bunch licorice, or the single insulated conductor over there. Other ways of conductor reconstruction, typically these are figures that applied in 2019, 2020. So 70,000 to build an overhead per kilometre to build an overhead line, 150,000 insulated, and about 500,000, or if it's difficult, 700,000 difficult digging. So clearly undergrounding is a very expensive option. And so, as I said, distribution utilities construct with this. Now, really interestingly, when you construct with ABC, the conductor may remain intact. And here's an example. So this was up in the Adelaide Hills, and you see the tree came down and the ABC was a bit stretched. I can't remember whether it was alive or not, but at least it didn't break and start a fire. So ABC is supposed to have that facility to stay intact, and the suspension assemblies are supposed to unravel and enable the conductor to fall to the ground and stay intact if it is hit by a tree. Wildfire effects on overhead insulated conductor. But if you've got insulated conductor, this is what happens. You lose not only the outer coating, but also the conductor inside. And of course, that's solved, isn't it, by undergrounding it. So here's a made-up figure. So I've got a large tree there, an underground line. Of course, everything's fine. No, it's not. Because the fire burns your low voltage network. You can see that transformer there. It was rather cooked. So underground assets are affected by wildfires too. Vegetation management. So one of the things we do in utilities, both in transmission and distribution, is keep vegetation away from our lines. This is the South Australian regulations, and I'll show you. So there's a clearance zone and there's a buffer zone. You see the clearance zone has no ceiling. That is, you can't have stuff overhanging. Similarly in Victoria. Now, why South Australia and Victoria? Because you know where the biggest fires in Australia happen? In South Australia and Victoria, in particular in Victoria. Although New South Wales might put their hand up to say they're in the game now as well. What happens in California? It's 18 inches or 4 foot in the high fire threat area. Now, most utilities don't stick to 4 foot. 4 foot is 1.2 metres compared to, you can see it, 2.75 to 6.5. That has a significant impact on vegetation, on fire risk, right? So California has fires, but most utilities are going for more than 4 foot. But the reason why they had that is because California is the place you want to be if you load up your truck and move to Beverly. For anyone who knows the hillbillies, they're very concerned about vegetation. They don't like it cut. So the regulator has lots of trouble coming up with clearances, but there has consequences. That has consequences. Imminent fault detection. So I mentioned this before, distribution fault anticipation. So real-time circuit health monitoring at the substation was developed by Professor Russell with EPRI, and it analysed the whole of the circuit going out of the substation. Low amplitude abnormal circuit behaviour, so arcing, device failures. You can see the plots there. Typically, you get these little blips on your otherwise regular conductor amps, and that equates to something. So there's an interpretation of that signal that's required, but nevertheless the technology's there. In Australia, IND Technologies, I think they're called, Professor Tony Marks and people who know Tony, early fault detection. The device listens for abnormal circuit signals, has limited range, so you need a lot of devices. These devices and this technology is being deployed, particularly in the US, for detecting incipient faults. But it's a preventative tool, asset condition monitoring. It requires interpretation of the waveforms, and it's not strictly for real time. I don't think they'd be comfortable using the feedback from there to actually trip a circuit. In other words, if they saw blips in a current circuit, would they automatically trip a circuit breaker? No. So it's really a preventative device. Broken conductor technology. So the aim is to trip the circuit while the conductor is still falling. Developers assert it works on circuits with high distributed generation penetration. Devices installed along the circuit in the substation, communications pass. So they talk to each other and suppose you can detect the conductor break in 200 milliseconds to 300 milliseconds. SWIR. Now, in Black Saturday, 3 of the fires that resulted in the 119 deaths were SWIR lines. And remember, RefCall doesn't clear SWIR. So a technology had to be developed, and that's where the early fault detection technology, that was the catalyst for the creation of that. It aims to trick a circuit when the conductor breaks and before the conductor hits the ground. So there has been a trial of this detection of conductor break technology in Victoria. There's a trial there, 5 SWIR lines, detection times 400 milliseconds to 1 second. So there's this technology emerging, still emerging. These are some of the sort of strategies for what people are doing to mitigate the risk of fires. Now, this is about as popular as, anyway. There's all sorts of analogies I could apply there, but I don't think I'd be put in jail or something. Preemptive power shutdowns to avoid power line initiated fires, right? So nobody wants their power shut off. You ask the people in Port Lincoln who had their power shut off 3 times in 1 year. So the public safety power shutdown, California Utilities and one Australian Utilities, that's SA Power Networks, has legislative authority to switch off supply if they form the opinion that it's too high, too risky to leave the power on. And if it's beyond their risk appetite. Risk. So how risk averse is an organisation? Who assesses its risk? It's a question. Assessment of risk is generally done. We typically use those risk matrices, right? They're easy to use, to understand, but typically it's about a it's something like, I think it's about a 1 in year event, that one. Studies show individuals can change their assessment. And what about a risk of an event that hasn't happened yet? And apparently there are techniques for calculating that. And an example of that is the probability of an asteroid impacting the Earth. So remember I said I was in International Wildfire Risk Mitigation Consortium. One of the presentations was by Douglas Hubbard of Hubbard Decision Research. He's a risk expert. He said, if you don't unambiguously quantify and document your risk aversion, your actual measurable, observable aversion to risk changes daily for reasons you're not even consciously aware of. In other words, today you feel good and you make an assessment on the risk. Tomorrow you feel crap and you make a different assessment. And that's bad from a risk assessment point of view. Studies have shown that the state of mind of a person can affect their attitude. So really important for risk. Why is risk important? Because that's what you're trying to mitigate. So the risk of starting a fire is asset fails, then an arc, then the arc produces sparks, so there's a lot of ands there. But typically on one of those really high, ugly days, all of the holes in the Swiss cheese line up. Consequence depends on the availability of fuel, the fire danger rating at the time, which is related to the atmosphere at the time. The more extreme the fuel and weather, the bigger the fire, the greater the potential losses. So here's sort of a little bit of theoretical stuff that I wanted to cover with you. So feeder A is exposed to higher fire danger, right? Because the hours on the y-axis, the hours over the period at a particular fire danger rating, and the x-axis is the fire danger rating. So feeder A is exposed to a lot higher, for more hours at the higher fire danger ratings compared to, say, feeder C. So and also the climate varies in different locations. You can have extreme weather and the wind gets up to 60 kilometres per hour in one location and maybe only 45 in another. So you've got these variations. What that all leads to is a different risk for your network. And you've got to conduct these like Monte Carlo studies of risk to give you a bit of a most probable outcome, to give you an idea of what your risk that you're managing is. Because remember, what you're going to do with that is then determine what your maintenance strategy is going to be, your management strategy, where you put your resources at your highest risk. So in fact, you can classify feeders, probability and consequence, and the risk is the probability and consequence. And at this stage, start collecting information about the number of customers per feeder and the supply off cost per feeder. Because what we're going to do now is we're going to rank the feeders from 1 to N. And somewhere along that continuum, we're going to determine where our risk appetite lies. Because we're going to have to decide, this is for power shutdown, public shutdowns of power. So the number of feeders that you switch off is really based on that risk appetite that you develop. So here's an example of two possible events where the people, the organisation on the left hand side, the yellow, they're prepared to wear a lot more risk because they'll only switch off feeder 1 to X. But the organisation on the right hand side, the green, they switch off a whole lot more feeder because they're not prepared to wear the potential risk from leaving all of those feeders alive. So this is the sort of considerations that utilities have to go through to determine when they use that power shut-off strategy, how many feeders they're going to switch off. So the risk appetite, it's adverse impact on the communities. Remember, you need to think about what that is with avoiding a fire start. That's what you're trying to balance. An example is when the criteria are reached, i.e. the fire danger index gets above a certain figure, we're going to interrupt power to 15 highest risk feeders. That equates to 14,000 customers for 7 hours, once every 5 years, to avoid a fire start of 500 million potential consequence. The community cost, you need to equate what that is. That's effectively what you're doing. You're trying to balance those two things, the community impact with the total risk that those feeders present. And that is very individual. That requires a lot of calculation. And remember, as I said, risk, you've got to quantify it rather than a gut feeling. It has to be quantified to give you the best estimate of what you're doing. So the criteria for power shutdowns, weather observations, clearly, what's the weather doing? What's the fuel quantity? Now, in Australia, just recently, we went from fire danger index of 2 fuel types, which was grass and trees, and now there are 8 fuel types. That complexity is probably causing a few little dramas with people who have to work with it. But nevertheless, it acknowledges that Australia isn't just 2 fuel types. It's a myriad of fuel types. And that's really important in terms of what happens when a fire starts. And it's important to strategy of maintenance and where you put resources. Live fuels and dead fuels. In California, they put people out to observe events. We tend not to do that. Actually, we have done that in South Australia. We certainly did for some of those events to see what the lines are actually doing, what the wind's doing to the lines. But obviously, you've got to do that very carefully. And reports of wind-blown debris, all of those things that you get from visual observations can be reported in, and real-time monitoring to detect arcing and low-magnitude incipient fault conditions. But that might be a bit too late to respond because the arc's already occurred, stuff's on the ground, you get a signal, you haven't responded, fire's already started. So distribution, the risk appetite is what can I live with to avoid a fire start? With transmission, what can I live with to avoid a line flashover? Because supply security and stability and supply interruptions occur if you let these flashovers occur. So transmission companies, as I said, you're not out of the woods. Other considerations, remember I said coordinating with firefighting agencies, you're all part of a big team on those sort of days. And it's really important for a number of reasons. One is to understand, because they do a lot of fire propagation stuff. There are agencies that support the firefighting agencies. There are Department of Environment and Water, these sort of people that model fire propagations and tell how far the fire is going to go. That's really important to be across and work with. And also, if you need to get into a ground to go and look at your assets, your power lines, be it transmission or distribution, you need to have good relationships with those folks. Weather monitoring. So the picture on the left is feeders in South Australia with extreme fire danger forecast. Right? So that we've highlighted the feeders in purple there, of the feeders at the highest fire danger. In California, they've put their 50-year wind gust map. So they've defined their areas. It's starting to get a bit more nuanced in where they put their resources. But connection with weather forecasts and observation services is essential. And what they've done a lot of in California is this. This is a South Australian example, but their own weather stations. They've got hundreds of weather stations to give them the feedback. Utility regulators, they're pretty hot in California, and Victorian regulators pretty pretty strong in their regulation. And the extent of oversight by regulators varies, and that's what came through in the survey. Climate change. Clearly, the intensity and the frequency of heat waves is going to increase. We know that. And as we saw, the intensity of the fire as a consequence increases. So it just increases the urgency for people to be ready. Insurance. So don't forget about insurance. If you ain't across this, if you aren't across your fire ecology and all of that stuff, and you project yourself knowing what your business is and what happens, then the insurance companies are gonna put your insurance premiums up. You've got to demonstrate a knowledge of what you're doing with your asset and how you manage your asset. In California, it's called inverse condemnation. They don't win. It doesn't matter. Liability for damages caused by their activity or equipment, regardless of fault or foreseeability. It's just it's crazy, but that's what it is, and that's why they go to nth degrees to mitigate the risk of fire starting. They've spent heaps of money. They're investment owner utilities. In other words, people invest in the companies. They're private, but they're investing heaps in that space. So the premiums are rising in insurance. So PPR learnings, preventive. Remember I said PPR, prevent, prepare, respond, recover. Prevent, there's lots of things you can do. Inspect, defect, repair, technology options, weather monitoring, vegetation inspection. What else can you? Exercising. Utilities do exercise with people to understand, okay, we got a fire danger day, who does what, who's going to do what, where do we do? Being ready for those days. That should be a no-brainer for all utilities who are facing high fire danger. Construction standards, divining your risk appetite, insurance cover, legislation to shut down power. Obviously, it's easier for us than in other states where they're struggling to get the legislation and shutting down power. So the day before, monitor your weather. Can you work out which parts of your assets are most exposed to that fire danger weather? Resource planning, first responder, communicate with your first responder colleagues. Customer communication, let people know what you're up to. In California, they've got to let them know sort of 7 days before, looking pretty bad in a week's time. 3 days before, I think we're probably going to switch off. The day before, we will switch off these areas for this amount of time. There's quite a strict regime. An enterprise, let people within your business know what's going on. And the respond on the day, disable, reclose, sensitive settings, remote and locally, firefighting resource, shut down power, first responder cooperation, coordination, and let customers know what you're up to. It's one of the things that saved us a little bit when we switched off power. We let them know what we're up to. Coordination, collaboration with firefighting agencies, as I said. Inspect fireground assets and repair fire. You've got to get in there with the firefighting agencies. You've got to collaborate, coordinate with them before you can get in there and fix things. So that's why it's important in the recovery phase. And so that's it. So in summary, the criticality of fires on assets, both distribution and transmission, has never been more urgent, because you can't ignore climate change. And what climate change holds in store for us is an increase in the number of these events and the intensity of the events. So I think what it behoves us as utility operators is to be aware of that and make sure our strategies are in line with those risks and those hazards that we're facing. Thank you. Happy to take questions if there are any. Stunned, yeah.
Sorry. One of the things you talked about early on was that the amount of fuel is increasing considerably. Is there anything we can do to actually, like, obviously there's burning, but is there better practices that can be used to reduce the fuel?
In Queensland, I'm aware in the western parts, where's that? That would be the northwestern parts. I have a friend who's in the national parks, and what they're doing is the Spanish firefighter that I'm telling you about. What they're doing is doing spots. They're mosaicing, if you like, their terrain to reduce the risk of the fire. Because if the more fuel that presents itself, the more and once it's gone, it's out of you forget it. It throws embers kilometres away. And as you saw in those videos, once it's gone, you can't stop it. So that's what you can do. And we talk about Indigenous uses of fire mitigation and that sort of thing. So clearly there are things I think we can do, and they must be effective because the fuel, you can see that graph that I showed, fuel, even in the same conditions, fuel is the biggest killer biggest creator of those extreme fires. Yeah.
Frank, Michael Lee. Question,
Michael, yes.
Were the working groups surveys able to highlight any correlation with electrical asset age to feed into the risk profiles?
Michael, we didn't go down that path. It's interesting. I'm not sure, so I can't answer that question. What I did was, when I was with SA Power Networks, one of the things I did was develop a model to model weather and the number of faults that we could expect from that weather. So, big data analysis, it's quite simple to throw it through a machine learning and come up with a model. The model came out to about 75% accurate. It missed the extreme ones, typically, right? But one of the things I said was, well, let's put into that model what the state of the network was at the time when the storm was there. In other words, if we had outstanding defects on there, did they lead to, and it resulted in 1% additional improvement. So I'm not sure that it will give us anything, Michael. That's on that basis.
Hi, Frank, Ken Barber, a great presentation. I've been involved in transmission lines and underground cables for 60 years. But last month I was involved in the inquiry in New South Wales into the feasibility of connections of renewable energy. And I had listen to the people, the general people who were involved in the bushfire in New South Wales in 2020. And one of the things I found most interesting is the firefighters talked about the fact that, yes, transmission lines do cause bushfires, and I never thought that happened. I was one of these people who thought, no, it didn't, but they gave 3 examples where it did. But the thing I found very interesting was when you have a major easement under a power line, it's usually in a straight line, and it's often around about 100 to 170 metres wide. And the firefighters said if there's any grass in that area, it's the worst thing that can happen, because if the fire is coming in that direction, it acts like a tunnel. And it happened in New South Wales. The fire went down a 330 kV line, which had just grass and some shrubs. But it went at a speed that was just impossible for them to control and burnt out $2 billion worth of pine plantations. So it's something to, if they'd have grown, now I understand they should have put a vineyard underneath the power lines. That would have been the solution.
That's great for
But
wine.
if not, you've got to take every blade of grass out of that area.
But isn't it what we've learned something, haven't we? That's really important science to capture and feed into whatever we do.
I think
And
so.
that and I think what really I learnt is you have to pick up every shred of information and try and understand it. Because if you know about it and you don't do anything about it, you're in trouble, both by the law and by your insurers. And there's one thing: be very scared, or be afraid, be very afraid. But yeah, that's a very good insight. Thank you.
All right. Srini from Energy Queensland. One of your mitigation solution, you talked about aerial bundle conductor, ABC, undergrounding the cable and those things. See, the other thing which you might need to think is the standalone power supply. So where you talked about swirl lines and those things, especially in Queensland Western region, what we're trying to bring into is the standalone power supply. That could also be the factor that you could reduce the bushfire because you no longer need the power line.
Yeah.
Because it'd be good, like if you guys add that one, comes as an
Into
additional
the- yeah.
justification.
I think I might have mentioned. maybe I mentioned it, maybe I didn't have it on the
Oh,
slide,
okay.
but certainly in WA, they're doing just that, getting rid of these long lines to a little area there, and all those long lines are a risk, absolutely. So that, and as I said, in California, they're doing it they'll leave the line there, they'll switch it off, but they'll have, PVs, solar panels, and a little generator at the end to supply that community as a way of mitigating it. But yeah, that's a very, very good point.
Emma Rogers from Powerlink. When the fireys are using the fire retardant, either as a preventative drop or a containment drop, they often use power line easements or power line corridors as a break. It's quite convenient for them. And my understanding is the retardant's corrosive and conductive, two things we love. Is there a best practice on at what voltage we should be turning lines off during the drop in case of arcing flashover, or is there a voltage at which we go transmissions?
You're going to study it. You're going to start it now. It's a great question. I mean, because maybe Michael has some more, but yeah, it's a very good point. It's a hazard that is out there emerging, but I don't know that we have much science. But Michael, do you have anything?
My comment is I believe ESCOM are looking into that.
It's doing that, okay,
So
South Africa.
I believe they were doing it. They have 765 kV, I think.
Okay.
So
Yeah.
I believe ESCOM had that as a concern, and I believe there are a group doing that.
I'll ask. So one of the people who was on my team is from ESCOM, Andreas. So I'll actually ask him because I reckon that's a great question. Thank you.
Any comment on Hawaii fires?
No, I must admit I was away for the last month on holidays, and I haven't followed some of the fires that have been around, so I can't. But was there any suggestion that it was electricity caused? Yep.
Comment from community, and I don't
Yep.
know if the evacuation wasn't done, that the electricity company has not switched off in time to prevent the fires. So they'll imply here that started
Yep.
firing to more than 100 people.
Yeah. Well, see, Hawaii being a US state, I mean, although most of the states in America, they have their own legislation. They're quite sort of independent in that regard. But the Hawaii, I don't know what their firefighting history has been like, but if they haven't, they certainly know about it now. But no, I don't know any more about Hawaii. Sorry.
Hi, Frank. Jack from the API. I noticed that only one utility in Australia has adopted the power shutdown procedure you spoke about, from a country that's, I guess, had so many bad bushfires. What do you think of the barriers from other utilities adopting this kind of procedure? And do you envision it as a procedure becoming more widely adopted? As you said, bushfires are more frequent and more severe than ever.
We haven't adopted it. So in 1983, we had Ash Wednesday. And in South Australia, the utility was government owned. And you can imagine the backlash on the government as a result of the fires, right? SECV 1977 had fires and they went a different path. Anyway, 1983, government owned. The government said, and we couldn't get insurance. Nobody would insure us after that. Big fires, 13 fires from electricity assets, big fires, $190 million damage, huge. So the government brought in legislation that said if it's pretty ugly, you can switch off. And in 1988, that was declared. No one else took up the challenge, even though Victoria had fires in 1983. In fact, after 2009 Black Saturday fires, the utility went out and said, they do it in South Australia, maybe we can get away with it in Victoria. Community said, no way, you're not switching the power off. It was too late. And in California, they bitch like anything when the power is going. I mean, they know about it, they've got the legislation to do it or whatever. But now what they're doing is setting up networks, hubs. So you go and plug your phone in to keep your charge, keep your fridge, you escape, but power's going to go off. But so I think it's a challenge to get that across. I know utilities in various states, because I've spoken to them, are trying that out with governments, but I think it's a bridge too far. However, the other strategies are we'll keep that community going by putting in a remote area power supply and turn this piece of line off. And that's what they're doing in America. That's probably the way it's going to happen rather than legislation. I don't think it'll get up.
Franco, one more thing. One of the other things I learned was that nowadays the firefighting procedure typically is to rely on aerial. And the aerial, there are rules. If a power line is on, they will not go out. So in the New South Wales fires, Transgrid refused to switch the power off because they needed the power in Sydney. And they weren't going to shut people down in Sydney. So all the power through that area, there was no firefighting by aerial.
Yep.
Now, we've got a situation in Australia where really the only way to solve, apparently, to get these fires under control quickly is by water, by aerial. Had they have just switched the power off for a short period of time, the aerial bombers could come in and the fire wouldn't have spread. So that's another thing we've got to learn.
It's interesting, in South Australia, on one occasion, because I was manager of emergency management, so I get this call from the State Emergency Organisation, the State Emergency Organisation, and the fellow who knew me, said, they're up at Para. Now, Para, for those of you who know South Australia, everything ends up at Para. Like, 275, the interconnect, everything ends up at Para. They're trying to turn off the power line. They're seeing sparks, because there's flashovers going across. They want to switch off Para substation. And I've said, what? What are they trying to do? So I've rung up Electronet and we had a bit of a chat and they didn't. But it does. I mean, that was just crazy because they were trying to switch the whole lot off. They didn't need to do that. But your proposal, I mean, why not? If for a short time, put that out. It may not be as easy that I don't run a transmission system. A distribution system would be easy. But yeah, you have to think about strategies like that. Because if you don't get on top of the fire early, gone. And then you're in no man's land. So.
Hi, Nicola Falcon. Just sort of a comment to add on to that. I mean, one of the biggest things with social license when we're looking at trying to build more transmission is the concerns around, how they might fight fires. There's a lot of volunteer CFA and everything out in the communities where we're looking at putting the transmission. And
Yeah.
I guess it's a sort of a comment and a question as to a way that we can have more understanding of what we can and can't do when we're trying to fight fires around transmission and distribution, because I think it would help not just our industry, but generally people understanding and building social license.
Well, that's why I think we're just one member of a community. The community is emergency management. So there are people who their daily job is to do fire propagation and fire information. And they're the folks that we should be talking to get an understanding and at least build that bridge between them. And that may help to bring the community on board. You've got to explain it to them. You've got to understand what it all means. And there's a lot of work. It's hard work, but it's worthwhile work. And that may be the way to do it, because there's got to be smarter ways of doing it. We've got enough nous around the place. Yeah.
Good presentation. Chart van der Walt. I saw your thing about risk, and I think it's a very good point, because if we know how TNSPs and distributors are going to respond when there's fires present, we can plan around that.
Yeah.
And we can still keep the system reliable and secure as much as we can with switching of lines. If we don't know and it happens randomly, we have no control.
Yeah, absolutely.
Thanks.
We tried. I mean, we tried to get to you guys, email, to let you know when we were going to do it, but I don't know how successful we were when we did do it. Having said that, fortunately or unfortunately, it was only one area of the state, and I hesitated to actually visit that area, given that we switched them off 3 times in 1 year, and I was the one that recommended it to the CEO. But that's that. I think that's. But if you're going to do it on a big scale, you guys need to know. Absolutely.
Just picking up on some of the points about the impacts of having a power line on some of the firefighting stuff. Did you look into much about how the fuel underneath a power line's managed rather than the fuel up top? Because I can imagine having a particularly transmission line might make it a bit more difficult to do back burning, bit more difficult if you've got a lot of fuel there.
We didn't specifically, Catherine, no. But what did come out of the study was this idea of building a mosaic of fire, doing the landscape like that. But no, not specifically under the power line, no. It appears that face of ground faults are not an issue really with the lower, but the higher you go up in volts, then clearly the flames get closer and closer, and the air gap needs to be much bigger with the higher voltages. So it's more of a critical thing, I think, for transmission.
Just we're talking about like social conscious with like lines and that. I know we get some customers and they want like a new 22 line through, quite dense bush.
Mm-hmm.
And, as a utility, it's not really something you want to entertain. It's a very small load, obviously not a lot of revenue. It's a lot of work to maintain that amount of, you got to maintain that easement, cut down a lot of trees. Sometimes it doesn't matter how many trees you cut down. If you've got 80-metre trees either side of the easement, it's still going to go down.
Mm-hmm.
I know at this point in time, we can't say we're not going to build that line for you. You need to look at an off-grid solution. At the moment, we have to. Do you think in the future we'd be able to say, we've looked at the risk and the risk is too high to build a new line out to you? You need to look at an off-grid system. Do you think that will happen?
Yeah, governments are supposed to reflect the opinions of communities. Now, I'd hasten to say maybe there's a bit of self-interest comes into governments, but that's being politically incorrect or something. So if the community feels that that's the best thing to do, then that should be reflected in legislation, because ultimately it needs to be legislated, doesn't it? You need to approach the community and get them on board, because otherwise it's just not going to fly. You might be able to, after an event like Black Saturday, that's the time to hit the market with changes and ideas of, no, we're not going to build. So in South Australia, every low voltage extension after Black Saturday had to be underground. Low voltage extension. The high voltage, we still went with overhead, bare. So we kind of went part way there. I think it just suggests it's a difficult one to bring off. But that's, you start building the seed, plant the seed and develop it. Keep developing the message and the story and see where it goes. That's what I think should happen.
Yeah, because price doesn't concern these people, which is a bit of the problem, that they very much want the line. But high risk area, it's the maintenance is just
off-grid solutions
high,
maybe, but it's going to cost. There's huge. If you're going to put in, we saw the difference in figures between ABC, IUC, and covered conductor versus bare. It's just and if they're prepared to pay it, that's it. But I don't know. You're allowed to charge customers for a reliable power supply, and if the standard is in high threat areas, and this is where you've got to legislate it, if standard is in high threat area, thou shalt build a covered conductor solution, then you're out of the woods. But if you're doing it, if it doesn't say that, you're snookered. You've got to go bare.
Just on that question there, just have a conversation about that. I'm all right, if that's okay. It's being recorded. Oh, it's being recorded, okay. So in that example with the putting in the overhead towards the person's house through that high risk area, when you look at the costs, you say, okay, bare conductor costs X per kilometre, covered costs this. But if that bare conductor causes a fire, the cost of that bare conductor is actually millions and millions of dollars.
Yeah.
So I guess the question is, when that gets costed up, normally when you would cost something, you would put a costed risk on every option.
Yeah.
And yet when it comes to the bushfire conversation, especially overhead underground conversation, that costed risk doesn't seem to reflect the bushfire. Is that something that does get reflected, or do you think it's something that hasn't been done enough?
Well, you and I both know that we've got to get the story through the AR, because at the end of the day, we've got to reset, and we put a budget together for a certain amount of dollars. And if every extension is going to be a covered conductor, then that necessarily means that there's going to be an increase in cost, and communities will kick up about that. So it's sort of in that it's a difficult one, I think, because you've got to bring a number of parties on board. You've got to convince the government that it's in their best interest to make it a fireproof type or fire risk reduced construction, and because ultimately it comes down to dollars and cents, and I think that's the challenge of getting a solution like that over the line.
So I'll just make a comment from Western Australia. So the standalone power systems that you mentioned earlier, they were actually legislated in, but it was based on an economic argument. So it was less maintenance. So while it has a benefit for bushfire, we sold it as you don't have to maintain excessively lengthy distribution corridors. So that's how we got it through. Maybe you could have the same luck.
Well, so in 2015 to 20, I put in an argument to the AR on bushfire risk management, right? And they said, no, we're not going to give you the money because we don't think you have as high a fire risk as in Victoria, for example. That was one of their comments. And your argument just doesn't stack up. You haven't shown a cost-benefit analysis, and your fire probability consequence stuff is not good. So in 2020 to 2025, the argument was completely turned around. We had a huge thing. It was a very small little, but it got up. The AR couldn't resist. They couldn't argue against. We had a very strong. So if you've got a strong argument to the AR, that's a good starting point, and you have to have that because it's going to be money. And you're right. If you bring in those other factors, make sure you've got good data to support that, so that bodies like the AR come along the journey with you. And then you can put extra money in your reset to ask for the higher standard construction. We're all done? Maybe we are. Okay.
No more questions? You had enough.
Yeah.
May I? Really, tutorial, when we have a tutorial, it's a special moment, really. Of course, this was a great tutorial, but the important thing is we receive a lot of information for young engineers. But more than this, even in my case, after 36 years of system operation, I told before to Franco, he gave me a new perspective, believe it. Because of course I was operating transmission system, but it's brand new for me. When you have to study, you have a lot of actions, you have to study a lot to make the system not the villain, not the problem, because it's new for me to understand that the electrical system can be the cause of the bushfire. In my life, I was only studying or trying to understand that the consequences from the bushfire for the system operation. But being the cause, it's another point of view. Thank you very much, Franco, for this great presentation. Franco Christi, please.
Thank you.
And not only for the presentation, this is the last part of the whole work of your working groups. And it's great because even receiving questions, we can imagine new working groups beginning from this point. That's okay for Study Committee C2. We are always open to new ideas and new studies. Franco, again, thank you. And before we go, of course, it's great because we will have time to visit the exhibition. Not too much, but we have some time to visit the exhibition. Remember, they are our sponsors and they are important for the whole event. After this, we will have a coffee break. And 3:40, we'll be back here. Not more with bushfires, okay? We will talk about the second part, that is restoration in this new environment of our electrical system. The second tutorial that will be presented from Study Committee C2, okay? We'll be here again 3:40, beginning the new tutorial. Thank you very much for your audience.
Very good.
Great, Franco, really.
Thank you.